This question given in GATE 2014 session 1 EC paper. The question is 5 JK flip-flops are cascaded to form the circuit shown in figure. The clock pulses at a frequency of 1 MHz are applied as shown. The frequency in kHz of the waveform at Q3. We need to find out what is the clock frequency of this output waveform Q3. The information related to JK flip-flops and the sequential circuit design can be found in this digital circuits course by Professor Santanu Chattopadhyaya, Department of Electronics and Electrical Communication Engineering, IIT, Kharagpur. So before solving this problem, we need to understand the functionality of JK flip-flop. In JK flip-flop, at the clock transition, if JK inputs are logic 0, so there is no change in the output Q. When J equals to 0 and K equals to 1, the output Q will be logic 0 and this complement output will be logic 1. For J equals to 1, K equals to 0, the output Q will be logic 1 and the complement output is 0. So this is also called set. When J equals to 1, K equals to 1, so this operation is called toggle mode. That means previous value of this Q will be complemented. So by using this information, we can solve this problem. Here, the clock is applied at JK flip-flop 0. Output of this flip-flop 0 is connected as a clock input to the flip-flop 1. So this is Q0. Similarly, output of this flip-flop 1 is connected to clock input of flip-flop 2. So this is Q1. Similarly, output of Q2 is connected to clock input of flip-flop 3. So here the clock is Q2. Similarly, here the clock is Q3. So all the flip-flops JK inputs are 1. That means when a positive clock transition applied at any one of these flip-flop, the output will be complemented. Initially, I assume all the outputs of these flip-flops are at logic 0. Assume a clock signal like this applied to flip-flop 0. So we know that J0 is 0, J0 is connected to 1 and K0 is also connected to 1. That means this flip-flop will be toggle at every positive clock transition of clock signal. That means Q0 initially is at logic 0, it will toggle at every positive clock transition. Like this. At every positive clock transition, the Q0 will be complemented. Here, the flip-flop 1, the clock input is Q0. That means Q1 toggles every positive clock transition of Q0. For flip-flop 1, Q0 is the clock input and JK is connected to logic 1. That means at every positive clock transition of Q0, the flip-flop 1 will toggle. That means Q1 will toggle at every positive clock transition of Q0. Here, the flip-flop 2, the clock input is Q1. See, here also, this flip-flop 2 also, the output Q2 will toggle at every positive clock transition of Q1. So initially Q2 is at logic 0, so it will toggle at every positive clock transition of Q1. Here, flip-flop 3, the clock input is connected to Q2. So this Q3 will toggle at every positive clock transition of Q2. We need to find out what is the frequency of output waveform Q3. If this clock time period is T, so Q0 clock time period is 2 times of clock. And this Q1 time period is 4 times of clock. And Q2 clock frequency is 8 times of clock. And Q3 time period is 16 times of clock. We know that frequency of clock is 1 by T. That means frequency at output node Q3 is clock frequency divided by 16. So the frequency at Q3 is clock frequency divided by 16. So clock frequency given as 1 megahertz, that divided by 16 gives 25.6 kilohertz. The frequency of waveform Q3 in kilohertz is 25.6 kilohertz.